Okay. We just finished the quiz. Everyone's very happy. How many people did well on the quiz? Wow, somebody just whistled. I like that. Wow, excellent. Everyone's very excited. They did very well. Almost every hand. You did well? Excellent. Well done there. Musaba, excellent. Excellent. Now, just put them on the keyboard back there. Stop whistling, Lizzie. I'm kidding. I know. So you'll hear a whistle once in a while. It's my phone. I don't know how to shut that thing off, but what I was saying just a moment ago before I turned the camera on is that we're going to do a little bit of an arc. In other words, we're going to be following the book, chapters 4, 5, 6, 7, 8, etc. But in the meantime, we're going to be doing we're going to try to put to good use some of the atomic theory we have been learning. Yes? Now, funny enough, I'm kind of teaching my 7th graders the same thing, but we're not going to go into anywhere near the same depth. But the videos I make for them are still good to watch. I'm putting them on both the 7th grade site and also the chemistry site. They're okay. So I expect, though, to move more quickly with you guys. Yes? Yes? Now, let me ask you, this is the main thing you have to be able to do. Are you ready? We're going to do a diagnostic test. Can you count?
No.
Okay, somebody said no. Okay. Is that Kamal? Okay. All right, that's Muhammad. Okay. Can you add integers? Okay, that's all you have to be able to do nomenclature and follow some simple basic rules. Now, picture the periodic table in your mind. Okay? Look at your periodic table. Everybody at home, look at your periodic table. Find sodium. Find sodium. Now, while you're looking at sodium, I want to talk about sodium for a moment, okay? Sodium has an atomic number, or Z, bless you, 3 times. Ooh, wow, call an ambulance. That's okay. You'll make it. Echinacea. Is that true? I hear that is not as true as it used to be. Echinacea. Purple coneflower. Anyway, I digress. Okay. Let me talk a little bit about sodium. Sodium has an atomic number, a Z of 11. It has the symbol Na. It's in group 1. Yes? Now, its ground state means that it has 11 protons and 11 electrons. So 11 positives, here comes the integer thing. You ready? 11 positive charges and 11 negative charges. So plus 11 plus negative 11 equals what? 0. Excellent. Now, when we talk about reactivity, we're going to talk about reactivity in some ways that the old chemists did. Did the old chemists know anything about atomic theory? No, they had no idea. But, so if something reacted in the periodic table, it reacted to be like what? It reacted to be stable, correct? And what is the definition of stability in the periodic table?
Full valence.
No, don't say full valence. Remember, we didn't know that. It has to be like a noble gas, right? Right? It has to be like a noble gas. So it has to have something in characteristics, it has to have something in common with a noble gas. Obviously, it's not going to have the same number of protons because the number of protons defines the element. Do you remember that? Yes? Sodium will always have 11 electrons. Yes? But it doesn't mean it has to have 11 electrons. How many electrons are in the valence shell of sodium? 1. Yeah, 1. What's the nearest noble gas to sodium? Neon. How many electrons does neon have? How many? 10, right? Would you say 18? You meant 10. Excellent. You were looking at neon but thinking argon. I understand. Uh-oh, that whistling again. We have a bird in the classroom. It's an excellent bird. Keeps us company. Ava likes the bird back there. She's giggling hysterically. Okay. So, matter of fact, all of group 1, how many electrons will all of the elements in group 1 give up to be like the nearest noble gas? 1. Okay? All right, so let's look at sodium. 11 protons and now 10 electrons. What's its charge going to be? Plus 11 plus a negative 10 is going to be what? Plus 1. Matter of fact, does all of group 1 attain a charge of plus 1? Nick? He's staring into space. I caught him. Nick, look at group 1. Is group 1 electron away from being like the nearest corresponding noble gas? Yes, it is, right? What's under sodium? Potassium. How many electrons does potassium have? 19. If it gives up 1, it's like argon. Yes? So it's good. They're all going to gain 1 electron. They're all going to lose 1 electron, correct? Now, let's look at group 2. Let's look at magnesium. How many electrons does magnesium have in its ground state? 12. What's the nearest noble gas to magnesium? Neon. How many electrons does neon have? 10. So what's magnesium going to do you think? It's going to lose 2 electrons. What will its charge be? Plus 2. So we could say very easily, group 1 is going to be plus 1. Group 2 is going to be plus 2. Is that okay? Can we say that? Yeah. Also, we want to say this. Side note. The valence electrons are only S and P. Valence electrons S and P only. Okay? Yes? Yes? Let's look at what's 3p1? What's 2p1 and 3p1? What group number? 13. So over here, we got group 13. How many electrons do they have in its valence shell? 3, right? 3. So it's going to be like the nearest noble gas, correct? It's going to give up 3 or take on 5. What are the odds? It's going to give up 3. What's 14 going to do? Carbon. It's going to go plus 4, minus 4. You can have two different ways of looking at carbon. You could say carbon disulfide, or you could say calcium carbide. Negative, positive. Clear? Some of this doesn't make a lot of sense when we talk about bonding. But you still have to worry about the valences, yeah? Okay, what about 15? Negative 3. How about 16? 17. Can you see that? Can I just check real quick? Can you see that?
Yeah.
Excellent. We're at the limits of the screen. Okay, good. So you understand that, right? You're okay with that? Okay, now, this is the next thing. The next thing is, I want to start putting things together. Let's say we take a couple of elements. You ready? Let's say sodium and chlorine. Let's say positive and negative, right? Positive on the left, negative on the right. Yes? And then let's say magnesium phosphide. Okay? This is how you do it. You write down the corresponding ion. What's the ion for sodium? The ion means writing down the symbol and the charge. What's sodium? What's the charge of sodium? +1. Isn't that how you do it? Yes or no? What about chlorine? Symbol and charge? Cl -1. What about magnesium? Mg +2. How about phosphide? You know what? I'm giving it away. Phosphorus. P. What is it? -3. Excellent. So far, so good? Now, here's where you have to be able to add integers. How many of each do you need for it to be equal 0? The lowest ratio, the lowest combination, the smallest ratio, the smallest combination of plus and minus charges to equal 0. How many of each? One of each, right? How do you write that? Isn't that it? Yes? How about this one here? How would you write that one?
3, 2, 2.
Mg 3. Is that what somebody said? When you think of 3 and 2, what do you have to think of? The least common multiple, which is what? 6, right? So 3 and +2 is +6. 2 and -3 is -6. You get it? How about something like, let's say something like aluminum and carbon, negative carbon. What would that be? Al4C3. 4 and 3, think 12, right? You get it? Or you could, in your mind. Yeah? Just a quick way to do it mentally. Yeah. All right. So how do you name these? This is binary nomenclature. How do you name the elements in binary nomenclature? How do you name them? All binary nomenclature. Now, what's binary nomenclature? The way we're doing it in our language that we have for this class, I'm saying that binary nomenclature is a metal and a non-metal. A metal and a non-metal. Okay? We are in the presence of greatness here.
And then I'm here too.
And excellent. So what was I saying?
Greatness.
Yes, greatness. Pop, interesting. Why don't Canada does November 10th.
11th, today.
But somebody said November 10th was Remembrance Day, or you say November 11th?
11th.
Or the 11th. We call it Veterans Day. We have the same thing, right?
Yeah.
Yeah, 11. Actually, it's coming up. 11, 11, 11, right?
We do a moment of silence.
Moment of silence. We're going to do here today?
It's up to you.
Excellent.
But we don't acknowledge it.
Understood.
Other than mostly Canadians. Thank you.
Excellent.
Sorry for the interruption.
See you later, guys. Okay, so where was I? Metal and a non-metal. So we're saying that binary nomenclature is going to be metal and a non-metal, right? Yes? Because you can have two non-metals, but that's going to be a different type of nomenclature. So binary nomenclature, you say this. You say the name of the positive ion, which is magnesium. Yes? And then you say the name of the negative ion with a suffix IDE. Yes? A suffix IDE. Yes? So what's the suffix IDE when you look at phosphorus? Phosphide. I know you got to play around with the ending a little bit. Phosphide. What about nitrogen? Nitride. What about oxygen? Oxide. What about sulfur? Sulfide. Chlorine. How about bromine? How about iodine? Iodide. That's a kind of a fun one to say, yeah? Okay, you get it? Yes? So what are these? What's this called? Aluminum carbide, or aluminium carbide for our European brethren here. Okay? How about this one here? Magnesium carbide. Magnesium phosphide. Yes? How about this one? Sodium chloride. Yes? Okay, now what I'll do is this. This is what I'll do. And then we'll look at this. All right, I want you to do this. I'm going to write a chart here. Okay. Does that look all right? Pretty good? Not great. Okay? And I want you to put some rows here. Rows. I want you to put rows there.
Sorry.
We have a request. Yes.
Mushba and Isma.
Ishmael's not here today. Musaba's here. You need him?
No, it's just he's marked absent.
Okay. Yes, he was here. Musaba, did you sign in? Okay, you got to sign in next time? Okay. Okay. All right, so now we want to say all kinds of interruptions, yeah? That's a school, right? Okay. So we have we're going to say on the left side we're going to say positive ions. Name me some positive ions. Quickly. Shout them out. Sodium. Magnesium. Potassium. Calcium. Aluminum. Boron. That's enough. All right. What about negative ions?
Silicon.
Carbon.
Chlorine.
Chlorine.
Bromine.
Sulfur, or sulfide, I should say. Chloride, carbide, you're right. What else? Bromide.
Chloride.
Oxygen.
We already did chloride. Oxide.
Chromium.
Chromium. Polonium, no. We wouldn't use polonium, but I understand that's actually a nice idea.
Iodine.
Iodine. And what else? Shall we say nitrogen? Yes? Then we're going to number these. Okay?